Welcome back to part 2. This is lesson 5.3 of solving trig equations. Example 5 says that cosecant x plus cotangent x equals 1. Well, you know from your identities that we have a relationship between cosecant squared and cotangent squared, but not the terms when they're not squared. So what I'm going to do is I'm going to move one of them to the other side, and then I'm going to square everything, and so that I can use some of my identities. I'm going to move the cotangent to the other side. That will give me cosecant x equals 1 minus cotangent x. Now, if I square both sides, I do need to make note, and I need to remind myself that if I'm squaring, that I may have extraneous answers. Extraneous solutions. And so I'm going to have to check that at the end because I squared something up here at the beginning, and that's, one or more of them, may not work. So I just need to make a mental note or a physical note that I need to check that. All right, let's continue with our problem. This gives me cosecant squared x. When I square this term out, remember that's 1 minus cotangent times 1 minus cotangent. FOIL that out. First term is 1. I will have a middle term of 2 cotangent x. My last term will become positive cotangent squared x. Now I'm going to bring everything over to the right side, and I'm going to rewrite cosecant squared x as our identity, which is cotangent squared x plus 1, right? Equals this product over here. Well, if I take everything to the other side, then, you know what? I could do that. If I take everything over here, so I'm going to move those over. I'm going to subtract the cotangent squared. Do you see how I'm going to have 1 minus 1? They're gone. I'm going to have cotangent squared minus cotangent squared. I'm going to be left with nothing on the left, and I'm going to have a negative 2 cotangent on the right. I can divide by negative 2, and I now have cotangent x equals 0. Well, remember that is sine or cosine over sine, and if I want to know where that equals 0, remember that's cosine over sine. Where does cotangent equal 0? That means cosine has to be 0 and sine has to be 1. Well, that's going to happen at sine is 1 and cosine is 0. That's going to happen at pi over 2 and 3 pi over 2. Right? So instead of just saying both those answers, I need to check both of them. I can't just say x equals and move on. I need to check both of those. So I'm going to check. I'm going to go to a different color. Let's go to purple. All right, so I'm going to go back up here to the original problem. And if I've got cosecant at pi over 2 plus cotangent at pi over 2, does that equal 1? Well, that's 1 over sine of pi over 2, which is 1, so 1 over 1 is 1, plus this would be cosine at pi over 2 over sine at pi over 2, which is going to be 0 over 1, which is 0. Does that equal 1? Yes. So we know that pi over 2 is a good solution. Let's try the 3 pi over 2. Cosecant at 3 pi over 2 plus cotangent at 3 pi over 2. Does that equal 1? This would be 1 over sine at 3 pi over 2, which is a negative 1. 1 over negative 1 is negative 1, plus This would be cosine at 3 pi over 2 over sine at 3 pi over 2. Well, that's going to be 0 over negative 1, which is 0. Does that equal 1? No. So my only answer then becomes pi over 2. It's my only solution. Let's try another type of problem. The next type of problem of equation I want to introduce to you are multiple angle problems. Multiple angle means that, if you notice, we have cosine of 2x. It could be 3x. It could be 4x. It could be cosine of x over 2. It is not just the x value or the theta value. You are now having to deal with multiple angles. So when you work this problem, I want you to first think about it as if it's only x. So this is like cosine of x equaling 1/2. Where does that happen? Well, we remember from our circle that cosine equals 1/2 up here at pi over 3 and down here at 5 pi over 3, right? So that's at pi over 3 and 5 pi over 3. So we're going to make both those equations. That would be x equals pi over 3 plus, and if you remember, since it's here in quadrant 1, if I want multiple angles, I've got to go all the way around. I have to add a multiple of 2 pi. And I also have x equals 5 pi over 3 plus, that's down here in quadrant 4, I have to add a multiple of 2 pi. Now, that's where we think of it just as x. The fun part begins because this is not just x. You have 2x. This 2 right here, okay, gives you a 2 here. We have to bring that down at this point. 2x. We really have 2x. Now, I want to solve the equation for x. So in order to get only x, I have to divide everything by 2. Everything by 2. If that was 3x, I would divide by 3. I'm going to divide by 2 on this problem. So I now have my x equals pi over 3 divided by 2 is going to give me pi over 6 plus, and now the 2's will cancel and I just have multiple of pi. Here, the 2's cancel. I have my x equals 5 pi over 3 divided by 2 gives me 5 pi over 6. 2's cancel. I have a multiple of pi. That becomes the solution to the cosine 2x equals 1/2. Now, what we just did, if you remember from your earlier notes, was we just solved for all values of x, right? What if I want specific answers on an interval? That makes it a little bit different. But if you do this first, it makes it much easier. So I already have the equations for all the values. So now I just need to go through and let n be 0, n be 1, n be 2, n be 3, however many I need to fit within the interval that I have set. So if I set the interval, let's pick another color. Can you tell I got new pens? So if we want to set this up to be on, usually they pick the interval from 0 to 2 pi. We'll just stick with that. Then I'm going to let x or n be 0 and 1 and 2 and as many as I can to stay within that interval. Here we go. If I let x be 0, n be 0, I know that I'm at pi over 2. If I let n be 1, then I'm at pi plus pi over, I'm going to need a common denominator. So before I start getting the multiples here, I am going to rewrite this as pi over 6 plus 6 pi over 6n. So I'm getting my common denominator. We'll just make life easier. Okay, this one would be 5 pi over 6, and I would have 6 pi over 6n. So here, if we let, you let n equal 0 first, okay, we're going to see if that one works. So that gives me x equals, if n equals 0, that's gone, and I just have pi over 6. That makes sense. We know that that's one of our answers. Okay. If I let n be 0, I'm at 5 pi over 6. Okay, now we're going to let n be 1. If n is 1, then I have 6 pi over 6 plus pi over 6, which gives me 7 pi over 6. Here, if I let n be 1, so we did 0, we're going to do 1. If we let n be 1, then I have 6 pi over 6 plus 5 pi over 6. I get 11 pi over 6. That's really close, guys, to 2 pi. 12 pi over 6 would be 2 pi. So I don't think I'm going to be going anymore, but I'll check. All right, if I let n be 2, if I come over here and let n be 2, then I've got 12 pi over 6, which is already 12 pi, or 2 pi, plus one more. That gives me 13 pi over 6. I'm beyond my interval. I'm going to stop. So that one won't work. Okay? I only have 4 solutions. Now, I'd like to show you a little trick. If you are doing 2x, then, and you normally would just have 2 solutions, then you double that because it's 2x. You know that your answer is going to have 4 specific solutions within that interval. It's just a little safeguard. If that was 3 and I had 2, then I should have had 6 answers. Okay? That is our lesson for 5-3. When you come to class, we will do some exercises in the book and solve more equations. See you then.